Welcome you all. In this discussion, we discuss about scheduling algorithm, the very interesting scheduling algorithm, first come, first served, that is FCFS scheduling. Here, look at that an example where we have a process and burst time. Process P1, P2, P3 we have. The P1 process burst time is 24, P2 burst time is 3 and P3 is 3. Suppose the process arrive in the order of P1, P2, P3. The same we taken that P1, P2, P3, 24, 3, 3 is on a burst time. In that manner it will arrive, the Gantt chart is look like that. First of all, the time started with 0 to P1 process executing at 24 times, so 24. After that, the P2 process executing 3 burst times, so 24. After 24, 25, 26, 27 time is taken for P2 and one more 3 times up to 30 is taken for P3. So the waiting time is P1 equal to 0 because it already allotted it first come and do it first serve. That should be the algorithm. Whenever the first job come for an scheduling, it first allocated. So first come first scheduling. So the first sum will allocated and started scheduling. So the waiting time for P2 is 24 because the first process P1 take the burst time of 24 until the 24 time units the P2 still wait to it to get its chance. At the same P3 is also wait for an 24 plus 1 more 3, so 27 time it's wait for to get its time. The average waiting time is 0 plus 24 plus 27 divided by 3, 17 is the average time. Suppose the FCFS scheduling will work in this order. Suppose P2 arrived first and P3 arrived first, and P3 arrived first in the sense the P2 only waiting. There is no waiting time because it's arrived first. So in the 3 unit of time it will be executed and P2 executed within 3 and P1 executed within the 6 times. So the waiting time ratio had entirely changed. So P1 has 6 and P2 has 0, P3 has 3. The average waiting time we have 6 plus 0 plus 3 divided by 3 equal to 3. Much better than the previous case. So what we learn in the FCFS is that the first come job have a lesser time, it will be better for an average waiting time and waiting time. The second algorithm is the shortest job first scheduling algorithm. So like in first come first serve algorithm, which job come first, it will be allocated to the scheduler to execute. In this algorithm, associated with each process, the length of the next CPU burst. Use this length to the schedule process for the shortest time. So it is find the shortest time among the processor. There should be two schemes there. Non-primitive, one CPU give to the processor, it cannot be preempted until the complete CPU is burst. Let me explain it in a simple manner. Suppose I am assigning a job to one CPU. The job time is 10 minutes. For an example, we won't broke that intermediately until the first job is completed its 10 minutes time, then only we get another job to assign. Primitive is not like that. Whenever the higher priority job is came, we burst the scheduling and assign to the another job. If a new process arrive with a CPU burst length, then the remaining time of the current executing process will be printed. The scheme is also known as shortest remaining time first. The JFC is optimal, giving the minimum average waiting time. Because in the setting process which has a minimum time that was allotted first. Example, you consider this 4 process P1, P2, P3, P4. Here we have one more column as arrival time. P1 arrived 0 time, P2 arrived 2 timing and P3 arrived 4 minutes and P4 arrived 5 minutes. Suppose P1, P2, P3, P4 have respectively burst time 7, 4, 1, 4 like that. The first arrival of job is P1, it have arrival time 0. So I am assigning P1 0 through it have a burst time 7, but it will be worked in the primitive, non-primitive phase and we work is as is 4. So total 7 minutes it's work. After that only we assign P2, then P3 and P4 depends upon that execution arrival time, depends upon the arrival time. Suppose it will be in the primitive pattern. I am just assigning a P1 in a zeroth waiting time. When it is worked out in the second time, first minute, second minute. Example, you consider as arrival time as 1 minutes. In second minute, P2 job arrive. The process P1 have 7 total burst time. 2 only it's worked out. So 7 minus 2, 5 remaining there. but P2 process have 4 burst time. So comparatively, the P2 job is better than the P1 job. So immediately P1 is preempted and P2 is inserted. Likewise, it will work. So the average waiting time, it had 9 plus 1 plus 0 plus 2 divided by 4 jobs. So 3. So in this way, the preemptive scheduling algorithm will work. It saves on time. So we getting the time calculation like that. So we saw that the prediction of the length of the next CPU burst. So it will be help in the primitive pattern. So the primitive pattern of working is benefited in this algorithm. Here I am showing a just two algorithm. You can understanding the two algorithm have a different pattern. One is which one job is arrived first, that will be allocated. Another, it have an arrival time. Based on the arrival time, it will work. So we choose a certain algorithm which is optimal for our problem, that will help us. Similarly, we have a list of algorithm. In upcoming discussions, we discussing such a type of algorithm. Thank you. It will be help you. I hope that it will be help you to understand the basic things. Thank you.